Hello, welcome back to John Jumpa. This is assignment number 7, C-Tech 243, MatLab 1, or Applied Compilation Analysis 1. This is for assignment number 7, as I said before, on polynomials. It's going to be not too bad as compared to the other parts, other assignments. There's 10 parts in this, or 10 sections. You have to define the following polynomials, generate and display each of the following polynomials, ditto to 2, but for the following, do the following calculations using MATLAB, same as above, express as whole polynomial and polynomial fraction. 6, the same thing as above. Find the roots of each polynomial. To determine the polynomials that have the following roots, find the derivative of each of the following, and find the derivative of each of the following, this time expressed as polynomial quotient. And you can get that all here in this packet that you will get. Blackboard. I could probably post the PDF in the link in the description below. But for now, what we're going to do is part 1, and I'm going to explain to you how to do this assignment but on MATLAB, but not how to do the long-handed way. The long-handed is right here, which just means that he gave us the answer sheet. That is our long-handed, and as you see right here, this is not entirely correct. This is just purely the answers I got from the MATLAB, and he doesn't want it like this. So in this section right here, I will not be explaining this YouTube video because you can look at the given example in the packet how to do the longhand. As I repeat again, the longhand or the answer sheets that I gave you in this packet is not going to be the same thing as the MATLAB. It's going to be more like creating a polynomial like this after receiving something from MATLAB as this. So instead of 1, it'll be S. Let's see, 1, 2, 3, 4, 5, 6. So s to the 6 minus 2 s to the 5th, and so on and so forth. So yeah, I'm not going to explain about this. I want to explain how to do is this. So part 1. Part 1 is asking to define the following polynomials. Poly 1 you have here for that polynomial. Poly 2 you have another one. Poly 3, poly 4. Simple stuff you're supposed to do in the diary. So you're not supposed to straight up write polynomials as s to the 6 minus 2 times s to the 5th. No. What you want is to write it like this. Poly equals bracket 1 minus 2. Where I got 1 and minus 2 is, well, as you see here in this polynomial, in the s, the number right next to it there is 1. The variable is, if there's no number right next to the variable, it's always going to default 1. For the 5th one, to the 5th, it's s has times 2, or in this case times 2 minus. So it's 1 minus 2 plus 3, or just 3, minus 3, 4 minus 3. And that's where we got it. To put in here in this poly. 1 minus 2, 3, 0, there's a good reason for that, is because you have to put all of them, not just the ones that are shown. So each polynomial is supposed to have 6, since the first one right here, the first one is usually the biggest one. So 6, 5, 4, 3, since there's no s to the 3rd, that will be considered default 0, because anything a variable times nothing is nothing, and we got nothing, so 0. So that's why we have a 0 here. Then negative 3 is to the second, negative 3 to the second, yep. 4, and negative 3, our last one in this polynomial, negative 3. So pretty much you're supposed to do that in the command window. As you can see, I did it in the command window and I just saved it already. And I created a assignment 7 .txt file. So here's what's going to look after you've done the assignment with all the stuff of the workspace. So yeah, plugging into the polynomial. So that's simple stuff. The part one's not that easy. This is easy. So generate and display each of the following polynomials. So we have to add up the polynomials. For sum 1, poly 1 plus poly 2, what you got to do is you have to create the same matrix. Like how many matrices are in there, the numbers. Because poly 1 has 7 variables, you could say. 6, 5, 4, 3, 2, 1, and 0. You count this as well. So in total 7. You have 7 variables. While poly 2 has 4. 1, 2, 3, 4. So 4 plus 6 is not the same thing. They're not have the same matrices, because in a matrix you can't add them up. You both have the same. So that means that you could have some zeros in here to have both of these have to be similar, to be the same. I'll show you in MATLAB what I'm talking about even better. Since I already did it. So poly 1, if you double click here, this pops up and you have your matrix, or a 1/8 matrix to be exact. So you have 1, -2, 3, 0, -3, 4, -3. And you will notice here there's a 0 here. That'll explain it later, because again, what I'm going to talk about again is matrices. If you want to add some polynomials, you both have both of the polynomials have to be the same matrix, same numbers. So in this case, the reason why I have zeros there is for here it is, for sum of 3. Sum of 3, you have to have poly 1 plus poly 2 plus poly 3 plus poly 4. Therefore, poly 1 is not the biggest one. It's poly 3 is the biggest one, because there's 8, and this one has 7. So if there's 7 here, right? That means you need one more. You need a 0. You got to add a 0 there. And that's going to show you how to add zeros to both of the polys have the same matrices, and therefore add them up. So part 2, liters equals zeros 1, 3. That means that there's going to be 3 zeros. 1, 2, 3. Makes sense, because for poly 1 you're going to need 7, and poly 2 you only have is 3. 4. My bad. 1, 2, 3, 4. 4 plus 3 is 7. So that's why you need to add them up. As you can see here, I did equal zeros. 1, 3. Add the zeros. Poly 2 equals liters. Poly 2. This here finishes it up. This right here just adds the zeros. This right here is liters. You're creating the matrix 0. This is just making matrix right here. That's making this in the workspace. And you're adding these 3 zeros in here. In the poly 2. So after having these both polys in the same matrix, you can add them up, and MATLAB won't give you an error saying, oh, you cannot add these polynomials up because they are not the same matrices. And I got this. I got the sum 1 there. And as you can see, you could do the same thing for the rest of the polynomials to get the sums. And off to part 3. Part 3. Ditto to 2, but for the following: diff 1 equals poly 1 minus poly 4, diff 2 poly 3 equals diff 2 equals poly 3 minus poly 4. You just gotta you gotta subtract the polynomials. And since after doing sum of 3, you have all the polynomials to be equal the same, you just straight up write diff1 equals poly1 minus poly4. Because if you actually try to add more zeros, you're going to have, instead of all the same matrix, you can have more extra zeros, and they're not going to be in the same matrix. So sum of 3 is really important. And part 2 to do part 3. Again, just write diff1 equals poly1 minus poly4, and you should not receive an error saying that matrices are not different, therefore you cannot subtract. And you can now do part 3. Part 4. Do the following calculation using MATLAB. Looks like right here you have to... let me just back it up a bit so you can see it. Multiply the polynomials. Easy stuff. So just write prod1 equals conv, parentheses, matrix, bracket, and just like what you did in the polynomials, you got to write down for each one of the variables of here. So it needs a 5, it needs a -2, it's good to need a -1 because the 1's right there, it's just not shown. It's default, -s, +3, and -2. Okay, cool. Times 1 is 0 because there's no s to the third, therefore 0, -2, plus 6, +6, and then -4. And and bracket, and parentheses, and semicolon, and then just write prod1, and boom, it should pop up in the screen. Yep. And then you could do the rest for the following prod, and now you know how to do prod part 4. It's just that the prod1 equal conv, the way that is you're multiplying these two polynomials by using a matrix, C. And part 5, here we go. Instead of multiplying, we are now dividing and multiplying. Wait, no, sorry, that's part 6. Part 5 is just dividing. So what you gotta do is divide these two polynomials right here, stated. So that means you do bracket quote 1, comma, rem1, rem for the remainder, and quote for the number that you get when you divide, equals dconv. Instead of multiplying, dconv will just divide these two polynomials. So parentheses, bracket as conv, and in this case you have to write is 4. Oh, there it is. 4, yes. 1, yep. -8, okay. -3, yep. 4, -2, -7, +1, and end bracket, comma, and for the next polynomial, which is 4, 2, 1. Interesting. I got a 1, 0, -2. 8 is correct. -3 is correct. Then after that, it should be supposed to be -1. And then 2. Whoopsies, I might have made a mistake here in my thing. I'll leave a note right here. See, on the side of things, you can easily mess up. Just a fix error. Any second. Poly. So it's not supposed to be a 1 here. It's supposed to be a... This is part 5, I believe, right? Yep. It's supposed to be a 2, then a 0, then a 1, then 8, and minus 3. Let me check if I did an error here. And then you write quote 1 to get the answer of the first part of the quote of the division, and then you get the remainder. And notice here actually 4 0 1 0 0 0 negative 3. The reason why these 4 are 0 is because you get your answer here, and then this is the remainder. As again, you'll see here in the next one. 0 0 0 0 0 0 0 and then remainder, because these zeros just represent these numbers, and then this is just a remainder. Let me double check if I did that correctly. 1 0 negative 5, and then rest are 0. That's good. And the next part would be 2 negative 1 5. Again, that's not right. Why did I wrote 4 and minus 7? Must have been I confused myself with. Oh, I see. Part 5 I must have confused with the values of part 6. As you see here, there's a 4 right here. Yeah, it could be easily seen. Yeah, there. Gotta watch out. So I didn't make a mistake there, so I'm gonna have to check for both. But instead of 4 minus 7, because I thought it was this, no, it has to be 2 negative 1 5 minus 1, and then you get your answer. Off to part 6. Now part 6 is the same thing of part 5 and 4, except both of them combine. As you can see here, to multiply them, you could just name the first part partial. So partial equals parentheses, bracket, of here, as you get here, 1 0 2 negative 4 3 2 1. All right, 1 0 2 negative 4. Yep, times 2 1 negative 6 3. That's good. Partial's right. Then after that, and bracket and parentheses, and then semicolon, then bracket q compo 1 comma r compo 1 is just, another name just to name it as for the division, and then the remainder. So equals decom, that's how you divide in MATLAB with polynomials, parentheses partial, so you get the multiplication, comma, bracket, open bracket, 1 minus 1 minus 1 plus 6. There you go. And then you get your answer right here, as you can see. And then you get your division and your remainder. And let's see if I did the same thing for the other one. Multiplication. So you have to square it. Yep. So partial 2 minus 1 3, 2 minus 1 3. Yep. Okay, put it in, and then you get for the division 4 and 7. And 4 minus 7. Supposed to be a minus sign right here, so I did make a mistake here as well. Be careful, MATLAB users. The smallest things, it's always the smallest things that can get you an error, a wrong answer, a mistake. Mistakes. Yeah. Now off to part 7. Part 7 is actually pretty straightforward. You have to find the roots of all four of them. So just write roots, parentheses, sign, poly 1, then poly 2 for the 2, and then poly 3 for the poly 3, and then poly 4. So you see here? Yep. what I got. Part 8. Determine the polynomials that have the following roots. Poly 5 with roots of -2, 4, -3, 1 plus I, and 1 minus I. So poly 5 equals poly, and just right here it's wrote -2, 4, -3, 1 plus I, 1 minus I. Then poly 6, -2, -2, 1, 3, and 6. Same thing here, same exact length. And just write poly 5 to get your answer, and poly 6 to get that answer as well. Straightforward. And now off for 9. Find the derivative of each of the following. Polyprod and polyprod 1, 2. Find the derivative of the product of poly 1 and poly 2, and find the polyprod 1, 3, and the derivative of the product of poly 1 and poly 3. So for that one, you just write polyder, der for derivative, and parentheses, open parentheses, poly 1, comma, poly 2, and there, straightforward, you get your answer. Here again, you got polyder, poly 1, comma, poly 3, and you get straightforward, you get your answer. It's the following. Not too bad. And the last part, part 10. Find the derivative of each of the following. The derivative of the quotient of each of them. This time, and expressed in a polynomial quotient. So it's a bit different now. You have to do a quotient. So instead of as this, polyder, you have to write bracket Q comma R and bracket for the quotient. You have Q, divisor, and then your R for your remainder. And then equals polyder, parentheses, poly 1 and poly 2. And then for the other one, Q, open bracket Q, comma R, and bracket polyder, parentheses, poly 3, comma, poly 4, and so on. You get this. And, well, that's pretty much it for today's YouTube video. And let's just end it here that be careful doing this assignment. It's very long. It's tedious. And just, the smallest thing is MatLab can get you the wrong answer. As you can see here, I got a mistake and I got to redo it again. But as I like to always say, third time's the charm. And really, this is the second time. But, keep going at it. Keep practicing. Please don't forget to subscribe. Hit the notification bell for more videos like this. Don't forget to smash that like button. And I hope this video really helped you and make a MatLab more enjoyable and tolerable, and understand how to do the assignment as well, and understand this new techniques that is being taught by me by Richard Meyers. So see you next time.